Welcome to today's Energy Central Power Session entitled Success with Line Sensing, Overhead and Underground. A few housekeeping notes we'd like to mention. We acknowledge that given the higher demands on internet connections where many are working from home, technical issues may be more pronounced. If for any reason we find the need to restart the event, we invite you to click the same link to rejoin us. All mics have been muted. If the sound is not clear on your computer, you may dial into the audio portion using the telephone number listed in the right-hand panel of your interface under the audio section. Today's discussion is interactive with questions from the audience and the moderator. We invite you to submit your questions at any time using the interface on your screen. Before we begin, we'd love to thank our sponsor, Sentient Energy, who made today's event possible. They are the premier provider of intelligent sensing, data analytics, optimization, and control technologies for the distribution grid. They help electric utilities make data-driven decisions to enhance the delivery of safe, reliable, and efficient power while preparing for the needs of tomorrow's distribution grid. Thank you so much, Sentient Energy. Now I'm happy to turn the floor over without further ado to our moderator, Mike Beeler, to kick things off. Mike, welcome to the event. You have the floor.
Thank you, PJ. It's a pleasure to be with everybody this afternoon, and thanks for joining us. Thanks to Energy Central, thanks to Sentient Energy, and thanks to our really great panel today. So you see our panel of experts from the utility industry: Ron Critelli from Florida Power and Light, Ajit Apte from Baltimore Gas and Electric, Arvid Simhardi from Pacific Gas and Electric, and of course Venkat Bal from Sentient Energy. So thrilled to have this great panel. We're going to talk about line sensing for overhead and underground lines and how that contributes to reliability and maybe even resiliency. We'll define resiliency. We'll see if there's an application. And then in the future, the data that comes out of this line sensing technology can be used for planning and for engineering on the system of the future as we start to incorporate more distributed energy resources into the system. We have more challenges with reliability and resiliency. So let's get right to our panel today. Again, PJ said we've got about 90 minutes. The first half of this will be presentations, some opening remarks, and then presentations from each of our panelists. And then we'll take the last half for Q&A. So audience, be sure to send in your questions and we'll get to them as best we can. And we'll give each of these four gentlemen an opportunity to respond and to perhaps add some stories from their particular utilities that are going to add some value today. So Ron Critelli, say hello to us, and then we'll go right on down the line.
Yeah, good afternoon. My name's Ron Critelli. I'm the Senior Director, Florida Power and Light, Power Delivery Engineering and Technical Services. So been in the company for 35 years. In my group, I actually have accountability for transmission and distribution facilities. So I have engineering, reliability, technical services, asset management, design and standards, a smart grid center, and more importantly, our strategies around where we are going with the grid. Thanks, Mike.
Yeah, thank you, Ron. It's great to have you. Ajit, take it away.
Hey, good afternoon, everyone. Ajit Apte, Vice President, Technical Services at Baltimore Gas and Electric. Very similar to what the previous speaker said, I have responsibilities for the engineering side of the house. In addition, I have responsibilities for the project management, project delivery of major projects. Very involved on grid of the future, where do we want to plan, where do we want to take it, various scenario analysis, and ensuring that we design the grid which is reliable and, as Mike mentioned, resilient for all the upcoming scenarios which will come through. So excited to be part of this discussion. Thanks.
Thanks, Ajit, and we're excited to have you, and we're excited to hear about what Baltimore Gas and Electric's doing in that older urban environment and applications of line sensing. So glad to have you with us today. Arvind, take it away.
Thank you, Mike. Good morning, everyone. I'm a senior manager at PG&E, and I oversee a team that is responsible for distribution overhead asset strategy. And similar to other speakers, really looking into how we can manage risks on our system due to overhead assets, and how do we plan for the grid of the future in the most reliable and cost-effective way. So Really excited to be on the panel and look forward to the discussion today.
Thanks, Arvind. We're excited to have you as well, and look forward to hearing what you have to say about the grid of the future and maybe weigh in on some of the challenges at PG&E, to be sure. Okay, Venkat Bal, what have you got to go ahead and give us a greeting this morning.
Hey, good morning, good afternoon, good evening. I know we've got folks from actually all over the world joining us, so excited for you to spend a little bit of time with us. Also, thanks to our panelists, Ron, Ajit, Arvind, and Mike. Thanks for pulling this together and getting us going. So a little bit about myself. I'm the Chief Revenue Officer at Sentient Energy. What does that mean? It means that I'm fortunate enough to lead a great team on the commercial side and our go-to-market strategies. I've been with the company about 6-7 years now. It's been a fantastic journey, growing the company, from pretty much its nascency to now doing fairly well in our segment. I'll be talking a little bit more about that down the line. Again, I think we've got a fantastic set of panelists over here. Worked with pretty much all of them on this panel, and I think the future is going to be great for all of us. So excited about this session. Thank you, Mike.
Yeah, Venkat, thanks for sponsoring this today. We appreciate it. Okay, so we're going to go back to Ron Critelli, and Ron is going to give us some opening remarks about some of the interesting things that they're doing at Florida Power and Light. He's going to take about 8 or 10 minutes, and we'll try to keep it conversational as best we can. But Ron, what have you got to tell us today?
Yeah, so we can go on to the next slide there, PJ. So I kind of open up with a little bit about Florida and Florida Power and Light. So as you can see, everything in the state of Florida that is colored blue is actually the FP&L territory. We cover about 5.7 million customers in 43 different counties in Florida. Some of the big takeaways is over 77,000 miles of distribution line, over 35,000 square miles to cover. One of the very interesting things that we have is you can see the amount of coastline that we have and the amount of exposure we do have to tropical events and salt spray contamination. Most of our customers live within 20 miles of the coastline, so that gives us another unique area on our environment here. We cover from mostly of our environment is a subtropical to tropical environment, which means it gives us lots of opportunities to get better. And we have vegetation that's really it's every single day of the year we have vegetation that grows. We don't have a season where we don't have to trim. So that is Florida. It gives us a lot of different challenges, and why our overhead line sensors and smart grid plays a tremendous role in our reliability and resiliency strategy here. If you can go, PJ. On this next slide, we're really big on strategies at Florida Power and Light. So this is our strategy that we developed back in 2013, and it's a long-range strategy of combination of our hardware. What do we need for our hardware development, communications? How are we going to handle the data, our algorithms, and also what are we going to get from that there? When what you really look at is we're trying to maximize that sweet spot. So since 2013, as we look at doing things with making the grid smarter, we start to look at buying technology that's going to help us out that 5 to 10 years out, and that has been our strategy for everything that we do. So like the overhead line sensors, we're really looking at it is just how do we bring information back there on the analytics so we can start going, how do we get more into predictive? One of our future looking at is not only making the grid smarter, but how do we actually get into the predictive? We can all deploy smart grid, but the real big savings is getting into the predictive and driving O&M out of the business and driving customer satisfaction up. We spent a lot of time probably in the last year or two on our algorithms, which have been really driving where we need to be.
Ron, let me ask you a quick question on that too. You talk about going back to 2013 and developing strategy. Did you know back in 2013 that this technology of line sensing, whether on overhead or underground, was something that you wanted to be looking at? Did you have, as you developed that strategy, did you say, okay, we're gonna zero in on this technology, or was this something that was still in development?
Well, we've been working with Sentient for a number of years, even prior to this. So we weren't looking just for a fault current indicator, right? That wasn't our end game. It was really a device that had, and it was able to capture waveforms and analytics so that we could bring them back. Now, we knew that the algorithms weren't going to be there, right? But it was that leap of faith of that's where we needed to go, was predictive, because we knew we would get the reactive done.
Good, thank you.
Is that?
Yeah, thank you. I just wanted to touch on that.
Yeah, not a problem. So if you go look at how we deployed our sensors, just our overhead sensors, next slide, PJ, is we really looked at, right now, we utilized a lot of the, actually we started with probably a lot of the MM1s and 2s, and then moved up to the 3s. But when you take a look at the end of the day, we decided on a tactical deployment on our sensors of every quarter point. It was something that made sense for Florida Power and Light. Everybody's going to have something a little bit differently. But we decided that every quarter point is where we wanted to be on this, so we can get some really good restoration out of that, along with our analytics and the data. So currently, we have about 33,000 sensors deployed. We've been deploying them since 2014. A majority of them are the MM3s on our overhead feeders. We have moved to the ZM1s, where of course the amperage was lower, and we've installed those on the lower amperage feeders, or at the end of the feeders, and along with on some of our laterals. We have now moved over with the UM3s, because what we're also trying to do is, underground is no panacea. It's not a silver bullet for everything. You still have issues there. And we really needed to increase our awareness on the underground area. So you could see that we still regularly deploy units. We will probably deploy another 4,000 this year. The reason is we're continuing to build feeders. We have a healthy growth rate in Florida. And along that, we inherited and bought out Gulf Power, which is our Northwest region there. We're starting to get that region up to full deployment and where we are. So the next slide, Pat. So how did we really incorporate this in our journey? And so what we chose was to work on penetration and ensure that we had our communications and that we understood the data first. So if you're really looking at this chart, we worked on the first 4 areas before we moved over into process change. So we really focused on getting high penetration first, making sure that we had great comms out there, and we actually use a mesh network for this. We understood the data. We got it developed into our DMS system, and we were confident on the results of that. Once we worked on that and got that down pat, we actually took all this information and actually funneled it into my smart grid diagnostic center. They were able to then use that data in the beginning to help out the command center to actually do during restoration. Once we fully got our, after the data confidence, in 2020, we actually moved over, changing our restoration process to fully going from midpoint restoration to fully being dependent on our overhead sensors and telling us where we need to go, where the fault was. All right. We've had really great success over the years on that. You know, and if you go all the way down here at the bottom bullet point, you can see that we've had 11% reduction in CMI per N, which really translates into about 12.8 million reduction in CMI. This has been a great complement. So again, overhead sensors complements the smart grid performance. Now, what we're really hoping for beyond 25 is getting fully into a proactive and predictive mode with our smart grid sensors, so we can go fix things going forward. Now, I do want to go back and mention, we have been using our AMI meters also as overhead sensors. I know people don't think about that, but doing so, we have actually already doing with our AMI meters for quite some time is actually predicting service drop failures, high impedance, along with finding out predictive what we call high voltage transformers. We can look at that the voltage is high. We got good analytics on that. We know if we don't change out a high voltage transformer in 30 days, it will fail. More than likely, it will fail on off hours, running up our cost. So we really start to do a lot of proactive. That is fully automated, no human intervention. When the system detects it, it actually sends a ticket to the service center. The service center has 30 days to close out that ticket. If they don't, it gets flagged back at our command center, and then we follow up with the service center. So we're really moving into using all of our sensors, moving it to automation where there's no human intervention, getting it to the service center automatically, and trying to really leverage our operations.
Hey, Ron, let me interject real quick. That's fascinating. So this 11% reduction is a combination of complementary technologies that you're using, like the AMI data, the line sensing data, and other sources of data?
No, I should have clarified that a little bit. This 11% reduction is just due to our the overhead and underground sensors alone.
Oh, wow. Okay. Thank you.
So the other stuff that we're doing with the AMI meters is on top of that. So where does Florida Power and Light really go forward? Pat, if you can move to the next slide. So we're really big on innovation here, always looking to how do we use technology to get more predictive and actually drive out O&M out of our business. So we just got done as our next new sensor development. We've actually worked with a company. We developed with them jointly an aerial transformer monitor and pad mount monitor. So we can actually bring back ambient oil temperature. It's GPS enabled. We actually can tell if the transformer has been hit with sensors. It has a little bit of pole tilt on there. We're bringing back more and more load current and some other different items on that. The other thing that we also developed with the same company is pole tilt sensors. We're able to strap that onto the pole about 15 feet up the pole. What that is doing not only for day-to-day reliability, if we see any movement from that pole tilt sensor, did we have a vehicle hit? Did we have something hit the pole? Did we get a tree in the line? So we can able to triangulate that. The more important thing is actually doing for storms. So after the storm leaves, we want to be able to know without any survey data how many poles are actually leaning or down. And that should probably knock another day or two off our restoration. Now, of course, we shouldn't have any poles down because we actually are building them up to 145 mile an hour, our distribution poles, but they are subject to direct hits of trees and other items. The next stage is really looking between our regulators. FP&L is a full, we use single phase regulation out of all of our substations. So between there and the first quarter point where we have an indicator, we have a little bit of a gap. So now we're using our regulator controls to do some more advanced feeder predictive analysis. It kind of complements what we already have out there, closing the last gap. The next one is we've actually now leveraged the UM3 in our vaults and our networks, trying to get better understanding and quicker restoration there. Anybody that has network and manholes and stuff like that, in Florida, everything gets underwater, so you have to pump out things to go find issues. So we're trying to leverage this to go ahead and give us some better pinpoints of where we think the fault is. And then lastly is our inside the vault monitors. We have gotten away from inspection of our vault monitors. So we do look at, we can do what's the fans look like. We actually have cameras in the vaults. So it's more of we're trying to get rid of O&M and go with more proactive there. We got flare cameras in some of our vault monitors. So that's kind of where we're moving, is really a full deployment of a totally automated grid and all the monitoring will be done automatically and not manually. So, Pat, if you can go. So where do we really kind of wrap up all of this is if you take a look at really paying attention to our slide here is, we got sensors, analytics. We're going to incorporate more of our drone, which has a lot of image recognition on that, right? To really kind of push us for reliability and predictive. And that's where we want. We want to improve our predictive tickets. We want to have superior storm response. We really leverage all of our devices during storm, smart grid devices during that, and enhance our situation awareness. So really the big things that we see we have issues with to try to get done is we have open neutral detection. That's always a big issue for us. How do we address our single node currents? How do you close out tickets using smart grid sensors and AMI meters? Eventually we'll get into power quality issues with more DER on the system, right? And really just enhancing our whole overall predictive there, because we want to start moving towards 100% predictive. And what we're trying to do is reduce a majority of our tickets now are on laterals and lower level devices, and that is where our O&M is. So we've done a great job on our feeders, driving those tickets down and our reliability up. But with the lower level tickets is where the O&M sits and where the customer dissatisfaction sits. And that is kind of where we're moving to eliminate that area with sensors and analytics and automation. So just the last page, kind of a little bit on Florida Power and Light's performance since 2014 on our SAIDI. So in state of Florida, SAIDI is measured in outages on a 1 minute interval. Anything a minute and more is an outage in the state of Florida. So you can have seen on the deployment of smart grid and overhead sensors, we've gone from 70 minutes last year. We just finished up at 48 and a half minutes here. The interesting thing is this also includes planned outages. So we run about 3 to 3.5 minutes on planned outages. So if you take that out, right now we're about 45 minutes with a mostly overhead system in Florida. I'm very proud of the business unit and the guys and deploying this stuff, and we've really delivered superior performance for our customers and the corporation. So turn it back over to you, Mike.
Okay, Ron, that's a great presentation. For the years and years that I've known you and the people at Florida Power and Light, you've always been challenged by reliability. And I know every year they set the goal lower and lower or higher and higher as it might be. And you guys deliver. So that's a great message, and I really appreciate it. And we'll move on to our next presenter. We're getting some great questions in from the audience. So keep sending those questions in. And Ajit Apte from Baltimore Gas and Electric, we're getting ready to come your way and have you tell us some opening remarks and some of the exciting things that are going on with overhead and underground line sensing at Baltimore Gas and Electric.
Sure. Thank you, Mike, and great presentation, Ron. If you go to the next slide, I'll provide a brief overview and background about BGE first. BGE is serving electric and gas commodities to the central Maryland region. It is the oldest utility. We started as a gas delivery utility, of course, then went on to become a common dual mode utility. Started in 1816, so it's been over 200 years now. We have 1.3 million customers and 2,300 square miles of territory. Pretty densely populated area, and as you rightfully pointed out, Mike, that older equipment and older utility has different challenges, and certainly we have those, no questions about that. A lot of our distribution network is actually underground. 66% of our distribution network is underground, and about 34% is overhead. Totally about 27,000 miles of distribution network. And we started off looking at sensors as one of the solutions for reliability aspects. And keeping in mind that we have to increase reliability, we have older infrastructure, we have weather challenges. In addition, if you see from sensors perspective, we can look at and get that predictive aspect, right, which Ron very rightfully mentioned. That's the goal, where we can predict rather than being reactive. And sensors also help us doing the planning, keeping in mind that we have aging workforce and how sensors play a role into that. We can go into a little bit more details later on, but pressure to maintain costs, let's ensure that we address the issues before they even occur, and that helps with not only customer satisfaction but also cost, reducing the O&M costs, right? So all those items played a role into why we decided to go more into the sensor aspect. Now, if you go to the next slide, we can go into more details here, how we got started. We got started more towards 2017 timeframe. And
Can I ask a quick question?
sure.
So when you do this at Baltimore Gas and Electric, you're an Exelon company. Is this something that's happening across the Exelon companies? Are all of the big metro areas that Exelon serves doing something similar, or is this unique to Baltimore Gas and Electric?
Certainly not unique to Baltimore Gas and Electric. Our sister utility ComEd is heavily into this as well, and we partner with each other. They have done a lot of overhead sensors. We have, since our system is a lot underground, we are not only doing overhead, but we are focusing on the underground portion as well. So no, it's across, and we leverage expertise of each other opcos to find the best practices.
Yeah, I would think you guys would have a great opportunity to do that. Thank you for sharing that.
Absolutely, absolutely. So we started, if you see, we started, in 2017. We wanted to first understand how this will help us ensure that our workforce is trained on various aspects of how these sensors will be used. So we started that pilot, and we decided to work with Sentient on this. And during the period, engineers and engineering standards organization did multiple things. We placed these sensors on 177 locations across the territory. The goal was to combine fault detection capability with load monitoring and capture the high resolution waveforms. We used the UM3s and MM3s, of course. That power harvesting technology, the beauty of that is we don't really require batteries, right? So that certainly was an attractive feature for us. We started deploying that, and another attractive feature, I would say is it can just be installed with a hot stick using the mount devices. So that was another attractive feature. We certainly use that part. We did that over about 12 months. We saw satisfactory results out of this, and then positive feedback from operations and the field folks as well. And once we got all that and we felt, yes, this is the right thing, we want to move forward, we started going into full deployment. And what we saw was how these sensors are interacting with the software, the front-end software, which captures all the data. I think that's a very positive part, and that's where we want to be. We want to go into more of the predictive nature, and combination of all these items really convinced us that we are on the right track. So
can I ask a quick question on that? So Sentient provides the software that helps to process the data that comes off these sensors?
Absolutely. So we capture all that data, and the Ample software unit gathers all that data. It has really good dashboards. The beauty is collect all that data and have those analytics developed. And as Ron mentioned about the waveforms, can we capture the waveforms at various scenarios, and can we use those waveforms to really predict what's going to happen on the distribution grid? That's where we want to be. We are still in the process of deployment, And the goal is to get to that point. We are not there yet, but that's the goal. If you move to the next slide, I'll provide you a little bit more details. The predictive nature, of course, that's where we want to be, but before that as well, what is the reliability improvements what we want to see? So this actually depicts how these sensors are used to find the fault, and it's very self-explanatory. I don't really want to go into details. If you see sensor 1, sensor 2, they show the fault is downstream, sensor 3 shows it's upstream. So you can see how easy it becomes for our field folks to really go and identify where the fault is rather than traversing the whole network, right? So our goal is to get about 1.5 minutes reduction in our KD once all these sensors are deployed. What we did was we worked with our command center and made modifications in our OMS application where the operators can really see on the system where the sensors show where the fault could be, and then they can literally call the dispatch organization that go to this area rather than telling the dispatch organization this is the feeder where the fault is. So it becomes much more speedier, I would say, resolution time, right? And it also in a way helps our improve employee morale as well, because now they don't have to traverse the whole thing. They can go and pinpoint there. So that's a positive employee engagement part as well. So I certainly want to mention that as well. So this is how we want to improve the KD aspect. And if you go to the next slide, I'll explain where we are in the whole deployment. We are about 56% complete on our overhead sensors deployment, and we are about about 70% complete on the underground deployment. There are a couple of things I would say we learned over the period as we were deploying, and one aspect I would mention is that we initially had decided that we will put 2 sensors on each feeder, but in some cases we didn't see that there is enough. So we had to change that, and we decided to reduce the number of sensors. We decided to deploy those sensors somewhere else. So just as a lessons learned, I'm mentioning what all things can go as per plan, but then of course you adjust accordingly, right? So just giving a background on where we are with that part. If you go to the next slide, I want to share where we are seeing the future use cases. And the future use cases, again, going back to the predictive aspect, right? Once we identify the descriptive and diagnostics, that is there, but how can we predict and use this data to really see where we can catch the issues before even they occur? We want to use these sensors for transform monitoring. We want to use these sensors even for the waveform classification and see what's really going on the grid. And the best part I would say is for DER telemetry. If we can get the voltage and current in real time, as PVs are becoming more and more popular and ingrained in the system, can we use that data to really help us with our distribution planning in real time as well? So those are the few future use cases which we really want to explore, and building that database, building that data set will absolutely help us develop those algorithms and see how we can get better at providing a more reliable service. That's where we are from future use cases perspective. And
Look, that's a great presentation, Ajit. I appreciate it. Let me ask you a quick question, and this question came from the audience. Who actually owns this data? So you're getting all this rich data coming off the system. You're 70% deployed on the underground. You're 40-something% deployed on the overhead. Who owns the data? Do you guys own it, or do you share it with Sentient, or how's that work?
Good question. So currently we are owning it, but we are exploring where, if we can share this data, and if Sentient has capabilities of, if they can develop the algorithms, that thing we are certainly seeing if that's a possibility. But the beauty is if they are getting the data from multiple places, I think that just gives more richer data set. So that's one enticing thing. So there are discussions going on, and we'll see how we can develop those things.
That's an excellent point. I think when Venkat gets to speak, he may be able to address that. But I would think that if they got all the data from all the utilities and they put their data analysts on it, that they could develop some great algorithms. Ron was talking about algorithms. I can see that would really, really be valuable for the industry. So, Arvind, we're getting ready to come your way. So, Arvind Simhadri is at Pacific Gas and Electric. They do a lot of really interesting things out there on a huge system, covers 2/3 of the state of California. And they've got all sorts of challenges with reliability and resiliency. And we're going to hear a little bit from Arvind. Arvind, we're really thrilled to have you join us today.
Thank you, Mike. And yeah, great presentations. And I see lots of synergies and completely agree with some of the discussions going on here. So just want to get started first with a quick overview of PG&E system. So PG&E operates in Northern California and has approximately 25,000 employees, and we serve over 16 million Californians. Right? And PG&E system consists of about 106,000 miles of distribution lines and 18,000 miles of transmission. And holding all these power lines together, there are about 2.7 million poles, with a service territory of about 70,000 square miles. So just wanted to give you a sense of scale.
Hey, Arvind, I guess 2.7 million poles, but you're going to start putting some of that system underground. Didn't your CEO announce last summer that about 10% of that system is going to go underground?
Yeah, so we're starting to ramp up to get 10,000 miles undergrounded, right? So it's a big focus, especially in the wildfire areas, to mitigate our wildfire risk.
Yeah, that'll be exciting to watch.
Yeah. All right, if you go to the next slide. All right, great. So I want to start off with a very high-level overview of PG&E's vision. So similar to other utilities, right? So our goal with line sensing technologies is to develop predictive capability that can help us detect these deteriorating asset conditions or hazards such as wedge contacts, and mitigate this risk before the failure occurs. And as you can expect, one of the key priorities for the company is to leverage this type of technology to mitigate our wildfire risk, right? Now, there are three key areas that we're working on to enable this technology. First is the sensors, so the hardware sensors that are out there in the field. So we continuously scan the market for innovation, but I've just listed some of the main sensor technologies that we're using. So we have the RF sensors, there's waveform sensors that we've deployed at the substations, there's line sensors, and we're leveraging a lot of our smart meter data, as well as data coming from our SCADA equipment. Now, once all this data comes in, the second piece is our monitoring capabilities. So being able to have continuous monitoring of this data across all three phases to look for anomalies on the system. Now, the third piece, which is probably the most critical, is analytics for decision making, right? This is where, this is the part that allows us to take all this data and leverage, data science capabilities to come up with trigger criteria and, come up with decision making logic. Right? So for example, we're starting to generate investigative tags for troublemen to go out to very specific locations and look for very specific conditions that these sensors are identifying. And I'll give some more details in the next few slides. So in the next slide, I'll give a little bit of double click on some of the core technologies that I mentioned. So first, obviously the line sensor. So these are our single phase conductor mounted technology, right? So we're leveraging that. The second one is called the EFD, early fault detection. And this is an RF sensor that we're piloting right now that is mounted right beneath the conductor. And we're installing them on poles every 3 miles. And these sensors can coordinate with each other, and they can triangulate disturbances on the line to pretty good accuracy. right? And then the last one there that I've listed here is a DFA technology, which is the distribution fault anticipation. And these are our current transformers and potential transformers that are installed at substations to monitor waveforms on the entire line segment from the substation, right? And then the waveforms are then classified to understand the types of faults that are occurring on the line. So in the next couple of slides, I'll give you a few more details on the EFD and DFA technologies. So this slide here kind of does a double click on the EFD technology. Right? So if you look at the picture on the left, you can see the sensors are mounted right below each phase of the conductor, and they're powered by solar panels and have the control unit right below it. Now, if you look at the middle image, the red fault indicator on the line, those are arcing, sparking faults that travel through the conductor and they get picked up by the sensors. And these sensors can then coordinate with each other and leverage locational information because they have GPS to triangulate exact locations. And what we're seeing is about plus minus 30-foot accuracy with these sensors. So if you go to the next slide, there are many ways to analyze this data that's coming from EFD sensors. So what you see here on the left, that chart is telling us where the disturbance is observed locationally and at what time and day. The bottom left chart there is telling us the magnitude of the detection energy. And if you look on the bottom right chart, that's kind of telling us on which phase the faults are occurring. So combining all this data, you can get very granular at telling our troubleman which pole to go and what to look for. So if you go to the next slide, I'll share some pictures. Pictures are worth 1,000 words. So these are some of the things that have been picked up. So you can see some broken strands of conductor, bullets in conductors, some squatting insulators, and then a vegetation that is touching our open wire secondary, and then also some bird caging and annealing occurring on our conductor. Now, if you think about it, right, these are all really difficult things to catch when you're doing visual inspections, right? So, and being able to pick this up and mitigate failure risks and also ignition risks is really key for us. All right. So we go to the next slide. So this is our substation mounted technology. So DFA, distribution fault anticipation. So as I mentioned, these are CTs, PTs installed in the substation, and you can see in the top left image there, these waveforms are sent into an auto classification engine, and this is the core part of the technology. So this software engine classifies the waveform into different types of faults. And the types of faults that it's starting to identify, you can see there, event number 2, failing hotline clamps. You can see event number 4 there, it's fault induced by conductor slaps. Now, one thing to note here, right? So DFA technology, because it's monitoring the entire line, it has a hard time telling you where the fault occurred. I can tell you what the fault it's seeing, but it's hard to tell where it is. So as you may have guessed, right, when you start pairing this with technologies like EFD or RF sensors, you can get very effective at finding specific faults on our lines. All right. So you go to the next slide. So as I mentioned, there are so binding all this together at its core is really, we have to build this analytical capability and analytical platform. So we are currently developing an integrated platform that takes data from multiple sources. So not just our sensor data, but it takes data from GIS, on our asset characteristics, takes outage data, takes our weather data, and brings all this data together, cleans it up, and starts looking for correlation. Right? And when you start getting data on, okay, I'm seeing line slapping incidents occur when we see wind gusts that are at this level in specific direction of the wind. That type of information really helps us take more predictive type of mitigation actions and mitigate our risk in a much more effective way.
Arvind, let me ask you a quick question. So you've got a fascinating amount of data that's coming in. So did you guys develop your own asset health center where you bring in all this data and then you're able to analyze it with let's say artificial intelligence tools or software tools that you developed internally, or do you have a product that you're using, or how do you take all this data from all these disparate sources and bring it in and then make heads or tails out of it for the system improvement?
Great question. Yeah, and that's been one of the core things, bringing all this data and connecting it together. So we have, so you're probably aware, we are working with Palantir. So we have Foundry platform that allows us to bring a lot of this data and tie it together to start building these correlations. So that's one of the platforms. We're still exploring other opportunities. We're also leveraging ADMS technology. So there's a lot of different ways. So we're still in the early stages, but first getting all this data together is really the big step, and then cleaning it up to make sense out of it, is where we're at right now. So I think getting into machine learning with AI is the future, but we're kind of in the foundational steps right now.
Okay, thank you.
All right, so just wanted to kind of summarize some of the things that we talked about. Just really 2 key points I wanted to make. So what we have found with all the work that we're doing is that each sensor has its own areas of strength, right? So line sensors can detect large overcurrent faults. EFDs can detect arcing, sparking. DFAs are substation technologies can tell what type of fault, but not where. So individually, they do not provide a full picture, right? So that takes me to my next point, which is ultimately all these sensors have to work together in a collaborative, automated fashion to come up with more proactive and real-time capabilities and detecting issues on our system. All right, I'll pause there. Any more questions, Mike?
Oop, I think Mike might be muted there, but let's go ahead and move along.
Sorry about that.
Ahead,
my apologies. Arvind, a quick question came in from the audience as you were speaking. Do your applications apply to your overhead system and your underground system, the things that you were just describing?
Yeah, it's a great question. So I focused a lot of my presentation on overhead, but yes, if you think about our DFA technology in the substation, that applies to underground as well.
Okay. Okay, so we're going to move on to Venkat Bal from Sentient Energy. So Venkat, as you prepare to tell us a little bit, you've heard a lot of really interesting things that are happening at some really big utilities, and some of them are using your technology, obviously, pretty successfully, it sounds like, both on the overhead and the underground. They're improving their numbers. We've answered who owns the data. Maybe you can expound on that a little bit. I think that's a great question. And then we did have a question from the audience coming in about attaching a dollar value to some of these improvements in reliability. And that's probably going to be best answered by the utilities. But Venkat, go ahead and take it away and tell us a little bit about what's going on at Sentient Energy.
Yeah, absolutely. PJ, if we could go to the next slide, please. So let's quickly talk about who we are first, perhaps, to set the stage a little bit. So we're actually part of Coke Engineered Solutions, and so we've got a ton of ability to continue to innovate and grow our platform. What you can see in the top middle over there is, an up to 20% reduction in outage time. You heard from Ron about 11%. You heard from Ajit about 1.5 minutes of CMI, I guess, of KD reduction. And we've done some work, including with actually PG&E, where we've come to about this number of about a 20% reduction in outage time. We've been very successful, with some of the largest utilities in North America, and that's important to come back on the analytics side in the next slide or two, actually, Mike, to pull in the thread that you were talking about in terms of data and how we use data. And so we continue to grow our platform with now the ability to look at grid edge control. You heard a little bit about EVs and PVs coming on the system and the need for power quality, understanding what's going on the secondary side of your grid is also starting to become very important. So we're very focused in our segment, on sensing control in the distribution grid, and working with folks, as Ron talked about in the FPL side, the lightning capital of the world, vegetation's a big issue. They need to go from, from restoration to predictive. You heard from Ajit on, the underground side, going to the overhead side, along with ComEd and PHI. And we've been very fortunate, also working on the wildfire domain. You heard also Arvind talk about that a little bit, where we've already got, actually a very large deployment in California, now looking at moving into other states and other countries that are struggling with this space. So we're really well, positioned to help the industry along all these needs that you heard from, from our fellow panelists. Maybe if we could go to the next slide, PJ. So why do we want to do this, right? So we're really focused on looking at, again, what we noticed actually was this digitalization and the need for flexibility is growing exponentially in the distribution grid. Over the last several decades previously, the distribution grid has had some investment, but probably not as much as what we've seen on the generation side and the transmission side. What's happening over the last 10 years and the next 20 years, we believe, is that the distribution grid is going to come under increasing stress. Now, what is going to cause those factors of stress or the challenges, is the incidence of renewables, EVs, V2G, and the general electrification of everything. We've heard about extreme weather situations, wildfires coming along. Hurricanes aren't getting necessarily much fewer, and the strength of the hurricanes are growing. So there's a big change that's impacting the distribution grid. And even when you start looking at, reversal of power flows, right, the bidirectional grid, all of a sudden things that have been traditionally looked at with one-way flow of power starts getting impacted. For example, your protection and control schemes, now you have to start re-looking at that. So understanding, your power flow, which way is it going, is also very important. I also briefly talked about the need to look at power quality, for example. Again, as you put stress on the grid, with EVs, with PVs, power quality starts to become an issue. And you heard, I think Ron was also talking about the need for voltage, and how do we potentially inject voltage to try and stabilize the grid? And with everybody starting to work from home, right, the WFH factor that's happening, the importance of reliability in the distribution grid and the electric grid has never been greater. So what do you do with all of that? And we started looking at this problem, and we believe that it's really important to provide visibility to our utility partners. So that really, the way we look at ourselves is, providing the folks on this panel and many others to be the eyes and the ears of the distribution grid. And that's what we're all about. PJ, perhaps the next slide. Okay.
Then Kat, I'll just add real quick. That was a great slide, and I think I'm going to ask the other panelists at some point in time to comment on that and the impacts on the distribution grid and what they're seeing at their particular utilities that are making those impacts. So great slide, great point, and appreciate you making that.
Oh, absolutely. Thank you. Can't take any credit for that. The team pulled that together, Mike. Okay, so you've also heard from all the panelists, and this wasn't planned, by the way, so I was writing some notes to myself, and it's absolutely fantastic to hear how aligned we all are in the need for a platform. So we look at the platform in the perspective, I mean, our customers tell us the same thing, right? Utility partners say, hey, it's important to have the full visibility of the distribution grid, whether it's overhead, whether it's low load, whether it's lateral or low load overhead feeders, whether it's laterals. And you heard a little bit about the undergrounding already. I know FPL's got a massive undergrounding program. BGE is already, I believe, from a percentage perspective, the largest underground system in North America. And of course, you heard Patty and the folks at PG&E talk about a huge program as well of undergrounding a bunch of their feeders, driven by resilience and reliability, right? And especially on the underground side, with undergrounding, the resilience aspect is becoming a big driver. So what do you do with that, right? What we're starting to see is, there are two modes of monitoring and predictive analytics that are important, right? When you first start undergrounding, as an example, the first 3 to 4 years, 3 to 5 years actually, you start seeing failures. It's a kind of a duck curve, right? And that could be because, everybody's trying to get these undergrounded systems quickly deployed. Oftentimes we see in those instances failing conductor systems, splices. Then it becomes really stable for 20, 30 years. And then after that, of course, you start seeing the impact of the aging infrastructure. So whether you're on the overhead side, you heard some folks talk about vegetation, conductor slap, or on the underground side, the need to really monitor and understand what's going on in your system has never been greater. So what do you do with all that data? Again, you heard from all the panelists. Yeah, you've got to start looking at an analytics platform. And taking all this data, understanding it, multivariate data, whether it's from sensors, whether it's from other aspects, such as drone data, weather data, SCADA data, GIS data, pulling all of that together is very important. So we completely, again, agree with what the panelists have said. And that's really what our next journey is looking at analytics to predict. And we believe it's very important in our analytics, our utility partners say, not just to predict, anywhere down a feeder, but actually to be contextual and have location specificity is very important, right? To understand where on your grid are you potentially going to have problems? What are those problems? And you heard Ajit talk about going all the way from diagnostic into prescriptive, and we'll talk a little bit about that in a couple of slides. So we've actually embarked on some programs together as as a consortium almost. We've got a bunch of data coming in, and now we're talking about how do we get this data from various utilities, Mike, to your point, and start figuring out how we can start helping each other in the utility industry. So again, early conversations. We believe it's going to be a powerful set of conversations to help the utility grid get smarter, more reliable, and more resilient. Perhaps we could go to the next slide.
And Venkat, as you transition to this next slide, you mentioned a consortium. A lot of people in the industry. Are there other utilities that you're free to mention beyond BGE and Florida Power and Light that you guys are engaged with right now? Is that something that you can talk about?
Oh, totally. So again, the consortium conversations are pretty nascent. So don't want to be saying that it's already done, but they are. We're already, for example, at at Sentient Energy leveraging our learnings from utilities across the world, actually, with each other. Not necessarily, obviously, disclosing whose data is coming from where, but it's again a very exciting time for the industry. In terms of the other utility partners, absolutely. I mean, we work across the board with Exelon. In various formats with companies like AEP, Pacific Core, so on and so forth. So we've, I'm sure I'm forgetting a few. I am Southern Company. In fact, I'm going to show a use case from Southern Company as well. Consumers, where actually, the CEO of PG&E came from, and on and on. So we've actually got 60 various utilities we're working with globally. And now the exciting part is how do you leverage all that data and all that learning across a global platform? All right, so we've talked about reliability a little bit. So let me kind of just drill down in the next couple of slides as to what the impact of reliability is. So it's really important for us. Sorry, PJ, if you could go back to the previous slide. Thank you. So it's really important, from a reliability perspective, to know where on your grid is the fault. So traditionally, various utilities have got different work methods and work practices. We've got a couple of utility partners that take two crews, send them out to the midpoint of a feeder, and then one goes left, one goes right. Other folks who've got, the ability to look at maybe downstream of a midpoint of a feeder, send a crew out there. But really trying to segment out your feeder to be more specific is very important. And there's numerous ways of doing that. You could take of course data from the sensors, and I'll talk about a fairly simple method in the next slide. We also look at GPS data. We look at again GIS data. We look at SCADA data, and also work with ADMS partners actually to help schema like Flizzr and Fisser to be more and more accurate in order to get to distance to fault. Obviously, O&M savings with that, faster dispatch, being more targeted with your dispatch, reducing your patrol time, better asset management. So all of these factors come together to actually get to a much more reliable and a lower operating cost factors for utilities. One thing we've seen at the bottom, if in terms of improving fault location calculation, we're actually being able to get down to plus a 2%, minus 2% accuracy to distance to fault. So very, very accurate kinds of location for faults. So again, this is in terms of reliability and reliability improvement. We've had a lot of success across the industry. The next slide, please, PJ. Okay, so a couple of different use cases that we're starting to see in the industry. Wanted to share that with all of you. So again, this very simple mechanism of restoration on the leftmost side, you can see, hey, we've got a fault somewhere, in this case where the X is at the bottom. So what do? You start patrolling that feeder, as we just talked about. But if you had some sensors around, line sensors on the overhead side, underground side, irrespective of that, you can basically look at, in this instance, hey, which is the last line sensor that saw, that fired, and so you've now narrowed down where on that feeder you've got a fault. So again, very simple way of letting your patrol folks and your distribution operations folks dispatch your crews. And again, with Florida, they do a phenomenal job. As an example of not just looking at ADMS, but also looking at Ample and other data sources to actually get onto conference calls and actually dispatch very accurately, very quickly. BGE is doing the same thing. Other utility partners are doing very similar things. Okay, so if you have a fault, where can you switch into? So it's important to understand what your assets are doing, where what your load is looking like across different phases. So first off, what are the different phases? A, B, or C phase? You want to be able to look at phase identification. Line sensors can help you with that too. So very simple form of analytics. You could look at things like load monitoring and understanding which feeders are where loaded in how much. And that helps you with also an asset management perspective. Next slide, PJ. I'm going to try and pick it up a little bit over here. So let's talk about a few successes that some of our utility partners have seen. Next slide, please. Okay, so here's the example at Alabama Power, where this is actually a slide from them that they've presented in the past, and I thought I'll use this. So they've talked a little bit about the benefits that they're seeing on the left, including the need for cybersecurity, which is a topic that we haven't yet touched on. And so we've actually gone off and worked with Alabama Power to do things like TLS, transport layer security. In the bottom, you can see what they are seeing is 79% reduction in this case to locate where a tree actually hit the primary. So incredible improvements from 2.5 miles down to 0.5 mile in terms of locating where that fault is in this case, and then further putting that into their ADMS system to get even more accurate, amazing results in Alabama. Next slide, please, PJ. So let's talk a little bit about the predictive analytics. So with another utility partner over here, you can see the journey from the top left, where we started looking at some of the anomalies from the waveforms. 2 weeks in advance, we started alerting, with our data science team together with this particular utility, very close cooperation, and we were able to report out 72 hours before the event that there's going to be an impending event with, in this case, an underground system. So you can see where the operations folks opened up in this case, the switch cabinet, and they started looking at, hey, yes, there indeed is going to be a fault. And that in this case, talking about economics, you'd ask Mike, in this one incident alone, a $70,000 value has been established. So that pays for the system pretty much on a per feeder basis right there, just with this one prediction that we were able to do. Okay, the next one, PJ. Here's another example. We talked about, Arvind talked about conductor slap. You can see on the left side, we had a warning the 23rd of May. The outage actually took place on the 26th of May. In this case, we had let this utility partner know, very much still in the partnering phase. So this particular one had not been rolled out across the entire grid. So and hence it went into a faulted situation. But again, it's just amazing to see the kind of specificity of where, and also providing a pretty good advance, 3 days in advance of where this particular outage happened. In this case, it was a wire down that was caused by conductor slapping. Next one, PJ. I believe this is the last one. So this is going to the descriptive side as well, that you heard Ajit talk about. And in this case, we had an outage that occurred, on the 28th of October, and we saw the spike happening, and we were able to look at, the causality over here was vegetation, but we were able to look at it, and we were able to tell them, after the fact, in terms of what actually happened over here, looking at some of the waveforms. Once that fault was cleared, you can see in the bottom left how all the anomalies just basically went away, and it had a very stable system. So you can see in the table below, we gave them basically a minute of advanced notification, but that's pretty important to be able to shut down that feeder, especially in wildfire scenarios and such public safety issues, to be able to very quickly react. PJ, next one, please. And I think that was the last of my slides. So, again, giving an overview of, the art of the possible and where the industry is really heading with some very exciting applications coming up.
That was really good, Venkat. Appreciate that. Ron, we're getting ready to come your way with a couple of questions. I will just comment, Venkat, that your ability to predict not only time, but in some cases the cost savings with some of these analytics is really, really impressive. So I'm going to ask two questions, and then PJ, you're going to actually get to hear from PJ. She's got some questions from the audience that she's going to offer up, and we'll let our panelists address them. We've got about 20 minutes left. And so we got lots of great questions from the audience. So Ron, I'm going to ask you a question, and then Ajit and Arvind, you can respond to one or both of them if you'd like. Venkat commented, Ron, on the stress on the distribution system. You see a lot of stress on your distribution system. That's why the investment's going there. Would you agree with his assessment about stress on the distribution system? And then the other question for you to think about is you talked about bringing this data into your smart grid diagnostics center. Maybe you can explain a little bit about what that is. Maybe Ajit, you've got something like that as well. You alluded to something like that, Arvind, as well. So Ron, take a couple of minutes and tell us a little bit about some of the stress on the distribution system, and then a little bit about your asset health center or your diagnostic center.
Yeah, sure. Well, we quite don't have it like a lot of other utilities in the system, right? What we do see, though, is an uptick on EV and also fleet vehicle EV. There's not a lot of solar panel penetration on the system. We have, like other utilities, we have seen a lot of some power quality issues associated with it. But really, the deployment of our sensors is really to drive reliability and cost out of the system. That is our main goal. So and actually having resiliency in the system. So those are kind of our big goals here, Mike, is really resiliency. We're undergrounding all of our laterals here in the next 20 years. And then we'll be in all of our feeders will actually be hardened to the appropriate wind loading code down here, which most of them will be 145 miles an hour, right? And that's all down to eventually we have this vision of restoring after a major hurricane in South Florida within 2 to 3 days. So that's kind of the deployment of what we're doing here. As far as the PDDC goes, that is our Power Delivery Diagnostics Center. We actually bring in all of our smart grid analytics, whether it's from the stations or transmission lines and distribution, actually into one center. We only funnel certain things into the control centers of transmission and distribution, so they can focus on the operations of it. The PDDC center is a 24/7 center that constantly is monitoring and looking for abnormalities and trying to get stuff out the next day, so we can be entirely predictive and forward looking. So that our philosophy is we wanted that center to be forward looking and not get caught up in the day-to-day stuff. It does support outages. It has a outage hotline for both distribution and transmission, and they do assist on providing additional information to the responders and to those control centers with additional information.
Yeah, you guys are doing some fascinating work. Ajit, what do you think about distribution system distress and maybe an asset health center, or where you bring this data back to?
Yeah, we are in the process of enhancing our data analytics capabilities for sure. And the key is, Mike, that we are seeing a little bit, but it's not, to Ron's point, it's not that much. However, the key is, if we start seeing the stress on the system, we're already late. What we need to do is prepare and take advantage of all these sensing data so that we can become more productive. That's the goal, and that's where we are going towards.
That might be the quote of the day. If we see it, if we see the stress on the system, we're already late. I like that a lot. Okay, let's go on to Arvind. Arvind, do you want to comment on system distress and what you're doing with the data? What kind of center you're bringing this data back to?
Yeah, for sure. So the first part of the question, system stress. Similarly, I think we're starting to see system get stressed, especially transformers getting stressed with EV loads coming in. But again, if you think about currently, the highest risk and highest priority is related to wildfire risk. So that's where some of the focus goes in, right? And that's kind of where we also see the risk inefficiencies, right? So we start seeing, so if you think about, we are doing public safety power shutdowns, right? And we are deploying, settings changes on our protection systems to be a lot more sensitive, right? So protection devices will detect current within 1/10 of a second, right? So this is so what we saw last year when we deployed these types of settings, there was 80% reduction in ignitions, right? But what that also does is adds reliability stress. So these are the areas where it makes a lot of sense to deploy this type of technology and, generate that benefit. So again, I think, I totally agree with Ajit. We're not seeing it yet, but if you see it, it's too late. So we are preparing for it.
So Venkat, run with that. If you see it, it's too late. But what I really want to hear from you is, you have a worldwide platform, and how many utilities are developing these smart grid diagnostic centers, these asset health centers, where they've got a central place? And I think Arvind had a really cool slide where he showed all these sources of data coming into one location. I mean, are you seeing that? What can you share with us about what you're seeing from your perspective?
Yeah, Mike, great question. So what we're seeing, globally pretty much, Mike, every major utility is either on its journey, has arrived at, a great spot, or is contemplating. So the data, the amount of data that's starting to become available is exciting. How do you harness the value of that data? The power of that data is what's being contemplated or executed on. So I do believe that certainly major utilities globally are well along their journey to have these diagnostic centers or diagnostic capabilities. Different utilities instantiate them in different ways, but the concept is fundamentally the same.
Yeah, and I think it just brings added complexity to the distribution system, especially as we start to add distributed energy resources onto the distribution system. So, okay, we're going to wrap up with audience questions. PJ, you've been there waiting in the wings, and you've got some great questions from the audience. Why don't you throw a couple questions out at us?
Absolutely. So I have a couple questions related to emergency response, and maybe Ron can start because Florida does get a lot of hurricanes. So I'm going to sandwich two of these questions together. The first one really is, having experienced in a hurricane after installing these sensors, how was your experience using the sensors during the emergency? And the second part to that question is, do you use that data to then dispatch to those employees who are trying to take care of the emergencies? How does all of that work?
Good question. When we take a look at this, we really were looking on emergency response. It's all about getting this stuff done quickly, right? So we're already out there restoring. So the data that we're getting usually is on the back end of, you know, the storms. We're using this in our storm forensics report to see if we can, you know, really understand what was causing the outages there. And then, so there's not a lot of it used during the storms. A lot of it though is on the after the storms, right? I think one of the biggest things what we've seen is, you know, you got a lot of crews out there, and where we saw, you know, what was supposed to be on A phase now is on C phase. So that is kind of how we've been using the stuff and accounting for all the sensors to getting back up. So as far as emergency response, you know, it's kind of right now it's been in our infancy. We've been just trying a couple things out.
And Ajit, maybe Ajit wants to respond to that too, because you get some big ice and snowstorms coming up for the East Coast as well.
Yes, we are expecting something over the weekend, but yeah, so what we have done is integrated this with our OMS system, right? So that's where the operators can really see where it is. So that it absolutely helps. And the more we install, the more data we would get, but at the same time, we would see where on the system it is. So it helps from that perspective, no questions.
Okay, how about another question, PJ?
Sure. So this one came in during Arvind's conversation, but I'm sure it's open to anyone. It says, do the same solutions, the same sensors apply to overhead as apply to underground systems?
Yeah, I think we touched upon that a little bit, right? So we do have underground sensors, but this presentation I focused it on overhead. The DFA technology, distribution fault anticipation at substations, do catch faults on underground as well.
Excellent.
Let me ask, PJ, let me ask a question of Venkat real quick. So Venkat, when you go in to present this concept, this technology, this line sensing technology, where do you go into the organization? I mean, who is it in an organization? Did you have to find a guy like Ron or Arvind or Ajit, you know, a man or woman that's got a passion for technology, that's got a data science background? Who are you looking for to become your internal champion to really take this and run with it if you go into a new utility?
You know, that's a great question, Mike. And I think, you know, the answer really depends. So for example, at PG&E, you know, we've talked to Sumit Singh, who's their Chief Risk and Safety Officer, and Sumit's like, hey man, we've got to figure this out. You know, in the case of BGE, Ajit and his team have absolutely been phenomenal partners. In fact, back to the undergrounding question and the need for, you know, different solutions. Actually, Ajit and the BGE team helped pioneer the work that we did to get these underground systems in place for the BGE system. So it really depends, you know, there's engineering folks. In a lot of cases, the pain resides with distribution operations. So there may be, you know, folks that are, you know, saying, hey, can you help me out? And then very quickly it becomes a very collaborative effort. Initially, I would say that there were a lot of innovation-focused persons that we'd be talking to at utility partners, but that's starting to, you know, as these platforms are starting to get more and more mainstream, it's less about the innovation, it's a lot more about the business cases and the particular needs, and that's a great thing to have happen.
PJ, have you got another question from the audience?
Yeah, Mike, there's one that actually connects to that. The audience questionnaire wanted to know which group in your organization actually manages that sensor data and performs the analytics.
So that sounds like a great question for the utility guys to answer. Ron, you want to address that?
Yeah, so that would be out of my reliability group underneath me. They're looking at this data. They work with we have some data scientists that they work with to manage all of that data.
Ajit, what do you think?
Yeah, Mike, very similarly, yes. We have in a very similar group of, whole engineering group where we have the data scientists. We also have the innovation group within that engineering group, which basically develops, and I wouldn't say develop, but indicates the culture, the innovation culture within the organization. And I know Venkat mentioned about the collaboration with Sentient on the underground sensors. Absolutely. That was a great effort, great collaboration. And it actually started, we funded that through our innovation group. And once we got the fruits, then we expanded that. So it's certainly within that engineering group, not only deployment, but piloting and even the data analytics part.
And Arvind,
Yeah.
you're probably that guy. Don't you have a background? Didn't you go to MIT or something? You probably got a background in that. You probably do this in your spare time.
Exactly. There we go. No, so we do have a team called the Asset Health and Performance Center, right? And this team has data science capabilities they're building, and they also have folks from the Operations Center and folks from people who know assets, asset health. So it's a cross-functional team, and they are leveraging data science and our Palantir Foundry platform to build these types of preventive analytics capabilities.
Well, PJ, I'd say if you got one last question from the audience, we'll give it to our panel, and then we'll start our wrap up.
Mike, if I could really quickly just interject.
Oh, sure.
One of the groups that we haven't talked about yet is also the IT organization. So we're starting to see, with a lot of interest in going to the cloud as well, from a scalability perspective, especially on the analytics side, that the IT organizations are starting to get more and more involved.
Venkat, that's an excellent point. We wouldn't want to leave those guys out. That's well said. Thank you.
I agree. I do have one that seems to have come up a couple of times, and really it's thinking of the future, right? So are these sensors just for what we have today? What about future distribution grid, the future DER integration? What challenges are there as we move that grid to the next level?
Venkat, you want to take that and start with that? I think you guys probably have a vision for the future of what you want to see happen with this impressive technology, and you have a worldwide perspective, and then we'll visit with each of our utility panelists as well.
Oh, absolutely. Thank you, Mike. So this is a conversation set that Ron and I have on a very regular basis, actually, as to where the grid is going, where with EVs, V2G, you start seeing these rolling, batteries, right, called EVs, electric vehicles, the Ford F-150 Lightning. Now you see, GM and Chevy starting to announce their units as well. So that's where the grid is starting to go, right? I mean, the generation sources are being democratized, and they're starting to be across various parts of the grid. That's starting to cause, again, a lot of interesting, situations. And then you're starting to see islanding, starting to happen in the grid. So, any platform that we're starting to develop, I think needs to have that scalability, not just in terms of, numbers and managing massive data sets, but also in terms of capabilities. Again, with innovation partners like, PG&E, BGE, FPL, so on and so forth, we've been able to continue to evolve and add on to the platform, right? And by the way, there's other companies that are doing this as well in the industry. So it's, again, a very exciting time with a lot of innovation happening. To directly answer that question, again, we kind of look at it almost like the iPhone model, right? Our goal was to put an iPhone on the wires. And so the ability to remote download apps over the air does allow for better analytics. It allows for better and newer applications that are constantly being dreamed up by, very innovative folks, some of whom are on this panel today. So I think it's really important for utility partners and the industry in general to be thinking about that agility to continuously evolve, given an infrastructure spend, and keeping the overall cost low. And we're seeing this everywhere, Mike.
Yeah, that's really well said. I like the word scalability too. I think that's important. Ron, your name was mentioned. You want to comment on that as well?
Yeah, I do think about things in the future, and I look at the number of solar plants at utility scale that we do have in Florida. And one of the big things that we constantly are monitoring is our power quality, or harmonics, right? And that's why we've really, as Venkat has said, as we get down more into EVs, more things happening down in the distribution grid, and PG&E's probably seeing more of this. Our biggest concern is going to be around harmonics, power quality, and then from, how is that impacting the transformers to the laterals all the way up into the feeders. So that's kind of where I think these sensors have a play in that, right? Again, with Ajit saying, you got to get this stuff ahead of time, because when you find out on it, it's too late, right? And I really agree with his statement on that, right?
Yeah,
so I think this is the whole power quality, you think, is going to be the new issue, and you got to really get way in front of it.
Yeah, that was a good point. Ajit, you're at one of the oldest utilities in America. What's the future look like at Baltimore Gas and Electric?
I would say it is green and bright. And no, we absolutely know what we have in front of us. It's not an easy task. There will be pressures from customer side as well, right? Reliability pressures, cost pressures. The key is, how can we be innovative, and rather than just putting more workforce to get the stuff done in a quicker manner, are there other ways where we can get this data and get the intelligence and use that intelligence to be more efficient? And sensor just is one of the ways to do that. So that's what I would say.
Arvind, what's your comment? You've probably got another 30 or 40 years in the industry ahead of you. What do you think about the future?
Yeah, no, this is near and dear to my heart. So I worked on DER technologies for a couple of years, and this topic is, I think, something we're going to continue to talk about. And I think there's so many areas we're working on, improving how much data we get from smart meter, what type of data we get, our ADMS platform, these sensors that are coming on the system that are telling us information, our drone technologies collecting, images, and really tons of data. I think the grid of the future really has to be very, very collaborative and connective, not just within a utility, but across other utilities and across, other industries. So I think, and we're excited about the opportunity this brings to kind of innovate in the space. And yeah, looking forward to how we build this out together.
Yeah, well said. Hey, PJ, thanks for the questions from the audience. We're right at the end. I think, Venkat, I'll give you an opportunity to say thank you and farewell to everybody, and then just everybody else can take just a couple of seconds to do the same, and then we'll wrap. But Venkat, bring us home.
Oh, absolutely. Thank you, Mike. So again, thank you to everybody who's listening in. Hopefully this has been helpful and thought-provoking. A special thanks to the panelists. I've absolutely enjoyed not just this conversation, but really the interactions over the last several years with them. Mike and Energy Central, thank you so much for pulling this together. I think certainly from a personal perspective, it's been absolutely phenomenal. So thank you.
Good, appreciate that. Arvind, how about you?
I want to say, I'm really humbled to be a part of this panel with, industry veterans here. I learned a lot myself just being on this panel. I really appreciate all the collaboration going on, and looking forward to continuing this and building this grid together.
Yeah, you guys are doing a great work at PG&E, and we're really thankful that you were able to join us today. So thank you. Ajit, say farewell on behalf of Baltimore Gas and Electric.
Thank you, Mike, and thank you, Energy Central, for inviting us to participate. Certainly honored to share what we have done, but at the same time, I learned a lot from what Arvind and Ron both shared, plus Venkat, what they shared. There's some things which I would absolutely want to emulate and learn from what they have done. So looking forward to more collaboration across the utility industry. Thanks.
Yeah, there was a lot of rich content. So we appreciate you being involved, and thank Baltimore Gas and Electric as well. And Ron, bring us home. And I know, Ron, what you're going to say is you're going to drive cost out of O&M, which is a great theme at Florida Power and Light, and bring us home.
Yeah, look, really appreciate being on this panel. Again, learned a lot from my peers. For everybody listening, I think what the key is we all have our same obligation. We're here to serve the customers. We're here to improve reliability and costs for everybody out there. And as more and more is electricity is not just something good to have, right? I mean, it's a basic need, and we got to figure out how we provide it during all types of weather, right? So everything that we're working on here, the more people that collaborate on the stuff and we share, the quicker we'll get to the end game, and we'll be able to get more predictive stuff out there in the future. So just, everybody keep on pushing. It's a great thing, and keep on networking. That's how we're going to really improve the entire grid for the entire country.
Well said, Ron. We do need to keep networking, and we do have critical infrastructure, and this distribution system in particular is getting more and more complex. So thank you, everybody, for joining us today. Panel, you did a great job, and Venkat, thank you for sponsoring today. We appreciate Sentient Energy doing that, and we appreciate Energy Central hosting this today. And on behalf of Energy Central and Sentient Energy, this is Mike Beeler saying thank you very much, and have a good and safe day.